Hello again everyone, welcome back to ptet.chemistry channel. So my name is Dr. On, and in this tutorial video we'll go through this November 2015 paper 2-2. So this is a paper 2 variant 2 for the Cambridge International A-level exam, which is suitable for any 16 to 18 years old students all around the world. In this first question, we gotta fill in the gap. So we are given quite a few rows in the table here, and each of them represent a particle which could be atom. Some of them are atoms, such as the zero charge atom. Some of them are going to be anions, and the reason why I don't put ion here is because there is a term called cation here, and when they use cations is to represent positive ions. So when I have negatively charged ions, I am going to use the term anions instead of a general term called ions. So looking at electronic configuration, we should be able to tell how many electrons we have, such as these 1s2, 2s2, 2p2. So that is 2 electrons in the 1s, plus 2 electrons in the 2s, plus 2 electrons in the 2p. There are 6 electrons total. And we need to know how many protons there are, and we can get that from the identity of the element. So carbon 13 is going to be carbon, and carbon has 6 protons in the nucleus according to the periodic table. It's element number 6, and carbon 13 simply means the mass number or the nuclear number, which is not the same as relative atomic mass, because relative atomic mass is the one stated in your periodic table. It says that this is relative atomic mass, and you know from AS chemistry, the definition of relative atomic mass is clearly something which is not the same as the definition for mass number or nucleon number. So they are not the same definition because they are not the same thing. So just be very careful there. So what do we have? We have 6 protons, so that's the number of proton, or what you will call atomic number. And if that is true, 6 electrons and 6 protons, that means we have 0 charge, because the number of protons equal to number of electrons when you have atom. So which means this must be atom. And I can go straight to sulfur 34. Sulfur 34 is going to be sulfur, which is element number 16 in the periodic table, and I have 34 nucleons. The mass number is 34, and since I'm an atom, so that means I must also have 16 electrons. So I'm just looking at the periodic table, and I'm just looking at sulfur. How do you go from hydrogen to sulfur? So 1s2, hydrogen and helium, then 2s2, lithium and beryllium, 2p6, boron all the way to neon, and then you go 3s2, that is sodium and magnesium, and then sulfur is the 4th element. Is the 4th element sulfur, 4th element in the P block. So you know it's 3p4 because it starts from aluminium, and then silicon, and then phosphorus, and then sulfur. So 3p4, 2 plus 4, 6 electrons in the outer shell, group 16 in your periodic table. Going back to the symbol for carbon 13, so you know these are the international standards, meaning to say we are doing the nuclide notations. So we are writing down the numbers to the far left. So 13 nucleons and 6 protons for the atom. Then sulfur 34 is 34 nucleons and 16 protons there. Now the next one is the second row represent a chloride ion with a -1 charge. That means the atom has gained 1 electron. We know that we know that chlorine has 17 protons, but now you gain 1 electrons because you have a -1 charge. So altogether you are going to have 18 electrons. And when you have 18 electrons, we are talking about a fully filled outer shell. So it's gonna look like argon. So 1s2, 2s2, 2p6, 3s2, not 3p5 but 3p6, because this is an ion of a -1 charge. The name itself comes just from the mass number, because this is going to be chlorine 37, since the mass number of the nuclear number is 37 there, and just because you gain 1 electron, it's not going to change your mass that much, since the mass of an electron is only about 1/2000. 2000 times lighter essentially than the mass of a proton or a neutron, which are the nucleons. They are the particles inside the nucleus of an atom. Okay. Now to ion 54, what you could do is you know that this is cation, so that means you cannot total up the number of electrons and get the number of protons. And besides, there's an easier way to get the number of protons. If you just look in the data booklet in your periodic table, the atomic number for ion is 26. So we know that the atomic number, the proton number, or the atomic number is 26 for ion. And then this is ion 54, so we are not doing relative atomic mass from the periodic table. So your relative atomic mass show 55.8. We cannot show 55.8, we show 54 because in the nuclear notation it's for a specific isotope. This is isotope ion 54. Ion, the mass number is the atomic number is 26, so there's Fe, and we have to consider that there's a charge, so there's 26 protons, and then I have 2 plus 2 plus 6 plus 2 plus 6 plus 6, as these are the number of electrons in each of these orbital. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 6 is 24 electrons. So I have 2 extra protons than electrons. I will have a net positive charge. I will have 2 extra positive charge. Therefore, I have a 2 plus charge there, this being a plus 2 cation. And like that, you get the easy 5 marks. Of course, you will do much faster in the exam where you don't have to explain to someone else and you're working with your own speed. But you got to be aware of the things that are confusing so that you don't make any mistakes in these kind of questions that are giveaway. In this second question, so we have the nature of bonding. We're talking about 2 spectrum of bonding. So what is meant by electronegativity? As stated in the syllabus, it is the power or it is the ability. We're talking about power or ability of an atom. We are not talking about molecule. We're not talking about ion. We're talking about an atom according to the specific definition. You can also see in the syllabus, of course, yeah. And this is to attract bonding electrons towards itself. So you're trying to attract bonding electrons towards itself. So when you are in a covalent bond, one atom which is more electronegative than the other will win the tug of war. The electrons will be closer to it and you will get a delta minus due to the electrons being closer to you. Now name and describe the type of bonding when you have equal electronegativity, things like chlorine and chlorine. There will be no winner in this tug of war because both of them are electronegative, but both of them have the same electronegativity, so they pull equally towards themselves, and as such there's no winner in this tug of war, and therefore the electrons lie exactly in between each of these, and therefore the bond itself is non-polar. And the whole molecule only contains one bond, and if the bond is non-polar, as a result, the whole molecule which comes from the polarity of this bond is going to be non-polar as well. This is element, and we know that it's non-polar, so you only have London dispersion force, or what you can call van der Waals forces, which is the same as London dispersion forces there. So what is the type of bonding when you have equal electronegativity? That's going to be called covalent bonding. Now they want you to describe the type of bonding. So they want you to describe covalent bonding. If you see in the syllabus, we do not describe covalent bonding as sharing of electron. That is the process. But then what we're talking about is what is covalent bonding. As with any type of bonding, we are talking about electrostatic force of attraction. But what is attracted to what? Electrostatic means something positive attracts something negative. In a covalent bond, you're talking about the shared pair of electrons, which is localized because it is kind of sandwiched in between the 2 atoms, the 2 nuclei specifically. So this is the localized shared pair of electrons, which are negatively charged, and they're sandwiched in between 2 positively charged nuclei. Positively charged nuclei, positively charged nuclei. Okay, that is the nature of the attraction, which is electrostatic, positive attract negative there. Now, how about when you have very different electronegativity? So we have something that want to gain electrons, they pull electrons very close to one side, and then the other one want to lose electron. Now you can see a pattern here which resembles what you had learned from your O-level or GCSE or IGCSE chemistry. This type of bond is going to be called ionic bonding. That is because you have the metals which tend to like to lose electrons and give you cations, and the nonmetals, being the more electronegative atom, would like to gain the electrons. So when we talk about ionic bond and we're asked to describe what is ionic bond, we don't talk about transfer of electrons. That is again the process. So as with any bonding, it is to do with the electrostatic force of attraction. But here, your lattice particles involve the oppositely charged ions, which are the cations and also the anion. So if you don't write oppositely charged ions, if you say between cations and also anions, it's perfectly all right. But if you write positive charge and negative charge, it's not okay, because when you have metallic bond, you also have something positive attract something negative. When you have covalent bond, you also have something negative attract something positive. So you have to specify what are the particles that are involved in forming the bonding there. Just to complete the story, of course, so metallic bonding has got nothing to do with these, because metallic bonding exists in metals, which are elements. So we're not necessarily forming any kind of bonding at all. But we do, because we have positively charged metal cations and we have the delocalized valence electron, that is for metals, whereas here you don't have the electrons, because all the electrons are localized. When you drew the dot and cross, the electrons are not floating around. They are inside the cations, they are inside the anions there. Okay. Question part C, we're given a bunch of molecules here as well as atoms. So this is F2. Argon exists as a single atom, as they are noble gases. They don't form any covalent bond at all. HCl is a gas until you dissolve in the water. Then it becomes a mixture, which is hydrochloric acid. So HCl is not hydrochloric acid when it is a gas, when it is pure. Methanol, CH3OH. Now explain why the boiling points of fluorine and argon are so similar. So when we talk about fluorine and argon, so both F2 and argon are simple molecular. In fact, all of them are simple molecular. Okay. Only need to break the weak London dispersion forces, or what we call van der Waals forces of attraction. If you like, you can use London dispersion forces, and this van der Waals forces of attraction is between the molecule. And how do I know that? Because F2 is non-polar, since they have the atom of equal electronegativity. There is no permanent dipole, and of course this argon, being a single atom, is not going to be polar on its own. So these weak van der Waals forces of attraction between the molecules, this depends on, first of all, the total number of electrons in the molecule primarily. So this is the primary factor, total number of electrons, not valence electron, but total number of electrons in the molecule. Primarily means is the most important reason, but you can see that fluorine, actually I'm not going to talk about the secondary factor. Actually, this is the most important factor, the total number of electrons in the molecule. And both F2 and argon actually have same number of electrons, because if you look at fluorine in your periodic table, 9 and 19.0, so there are 9 protons in one fluorine atom. And when you have 2 fluorine atoms, how many electrons do you have altogether? You will have 18 protons, and you are a molecule with no charge, therefore you have 18 electrons. So you have 9 plus 9, which is 18 protons. But because molecule have no charge, therefore you will also have 18 electrons. Since the molecule has no charge, molecule is uncharged. And then you look at argon. Argon definitely has 18 electrons in the outer shell, fully filtered shell. You can do 2-8-2 configuration, like what you did in secondary school. Not 2-8-2, 2-8-8. Okay, 2 in the first shell, 8 in the second shell, 8 in the third shell. So 2 plus 8, 10, 10 plus 8 is 18, 18 electrons, 18 electrons. Same number of electrons, same total number of electrons in the molecule or the atom, similar strength of van der Waals forces. So I can say, therefore, similar strength of van der Waals forces that you need to break, and therefore, similar boiling point. Very, very similar there. Okay, oops. Now the next bit, why is the boiling point of hydrogen chloride so much higher than the boiling point of fluorine? When we look at hydrogen chloride, HCl, Hydrogen has 1 protons, this is from hydrogen, and then you have 17 protons from chlorine, because chlorine is the 17th element, and then you get 18 protons. Surprise, surprise, because it's a molecule, so that means there is no overall charge, therefore you must have 18 electrons in HCl as well. So having said that, 18 electrons in fluorine molecule, 18 electrons in HCl molecule, it can't be due to van der Waals forces, it has to be something else. So this one is actually a result of permanent dipole. As you could see, hydrogen and chlorine have different electronegativity. Chlorine have much higher electronegativity than hydrogen. So I can say chlorine is much more electronegative than hydrogen. And as a result of it, you are going to have a polar bond. So therefore, HCl bond and overall HCl molecule is going to be polar. But F2 is non-polar since the atoms have the same electronegativity. So what happened is we need to breaking permanent dipoles, and this is between the polar molecule. So between HCl molecules require more energy, and that is why you have a slightly higher boiling point, because you require more energy to break the stronger permanent dipole than breaking the weaker van der Waals forces or the weaker London dispersion forces. Something about comparisons of the energy required, energy expenditure, that should be alright. Last but not least, why is methanol having the highest boiling point out of all of them? You can see the trend now. Actually, I didn't have to calculate the number of electrons. I don't know why, but I should have read the question. Equal number of electrons there. But of course, it was quite fun to actually show you how they have equal number of electrons based on the number of protons, equal to the number of electrons since these are all molecules. So methanol must have 18 electrons as well, but the boiling point is so much higher. So we talk about permanent dipole when we compare this polar molecule, and CH3OH must be polar as well. But between just the normal permanent dipole versus this, which must be a very, very, very strong permanent dipole, this must be the strongest intermolecular forces of all, because I know the question didn't ask for it here, but when the time comes, there might be a time when they will ask you to draw and show the hydrogen bond, between the molecule, or use a diagram to explain why the methanol has the highest boiling point like that. And of course, we label dipoles. We have to label delta plus and delta minus, and we have to have 2 different molecules. We're talking about boiling point, so both of them must be the same molecule. Between the molecule is intermolecular forces, from the lone pair of the electronegative atom to the hydrogen bonded to very electronegative atom, fluorine, oxygen, nitrogen, the 3 most electronegative elements, conditions for forming hydrogen bond there. So methanol must have permanent dipole, but methanol must have a very strong form of permanent dipole. Methanol can form hydrogen bond between its molecules, but that is a statement that is not explaining yet. So can form hydrogen bond between its molecule. So we need to make a qualifying statement. So hydrogen bond is much stronger. Hydrogen bond is much stronger than just a normal permanent dipole. And also van der Waals forces. So we require a lot more energy to break. So therefore, H bond or hydrogen bond needs or requires a much larger amount of energy to break. Do you need to show the diagram here? No, you do not, because the question didn't ask. But I'm just saying that in certain years, in certain type of questions where they do ask you, show with a diagram, explain with a diagram why it will have a highest boiling point. Well, there you go. And you have to know how to do this in AS level, because it's an AS level question and they can ask you in A2 as well. That's the end of that 17-mark questions. Very good start to this paper so far.